Okay, let's do that. All right. Thanks everyone for joining for the third and final UW GIS Professional Programs Map Chat of the fall semester. Today, we are very lucky to have one of our PhD candidate students, Atlas Guo, who's going to be presenting on his own personal cartographic journey and hopefully share some tips with the rest of us. Atlas, like I said, is a PhD candidate in the Department of Geography here at the University of Wisconsin. He's an award-winning map maker. Many awards. You can go look at his bio or website. He's got over 30 relevant mapping-related awards from NACIS to Esri, WLIA. Some of his work has also been featured in various publications. He's in my previous lab that I was in, the spatial computing data mining lab, as well as some work that he does in the cartography lab. His research focuses on GeoAI-powered spatial temporal analysis and visualization for natural disaster management, which is something that is personal to my research interests as well. So with that, I'm going to pass it over to Atlas, and he will kick us off on our cartographic journey. Take it away, Atlas. Thanks.
I might need to share again to make sure I have the sounds. Yeah, since I do have a short video clip. Okay, can everyone see my screen? I mean, online, see my screen? Okay, thanks. Yep. So thank you so much for inviting me, and I'm so honored to be here as a speaker. I know our previous speakers are excellent scholars and cartographers, but not me. So my name is Chen Xiao, and Chen Xiao Guo. I go by Atlas. I'm from a city called Zibo in China. I had my bachelor's degree in GIS from Stanford University and Master's of Science in Geography from University of Georgia, and right now I'm doing my PhD program. So I'm a grad student member from Spatial Computing and Data Mining Lab and also Cartography Lab, and previous intern at local Institute for Local Self-Reliance and United Nations Development Program. My previous research, actually current research, are more about spatial temporal analysis, and just as Chris introduced, it's not that related to, not that tightly related to cartography, though I changed my dissertation title to GeoAI-powered cartography for natural disaster management. But actually cartography is actually in parallel with my research, and after graduation, I guess I will just turn totally into cartography. So I choose this title for this page, my cartographic turn from GIS to cartography. So my motivation to switch my career goal, first of all, is the same as everyone you, lifelong love to maps. And also a very important factor is during my TA experience here, especially in intro GIS, intro cartography, graphic design, and interactive photography, I really feel like this is the true field that I will get myself involved in the future. And also the conference experience of NACIS or North American Cartographic Information Society since 2020, the virtual one, also helped me confirm my decision. So during these years, I also have an internship which is also focusing more on cartography, either static map making or web development. And the other important factor that drives me totally to cartography is the dashboard about COVID-19 during these years. Since it's so critical to me, so I decided to introduce this one at first before moving to the real cartographic themes. So this is a COVID dashboard I built during the pandemic years. It lasts about 3 years. It's a totally voluntary, non-academic project. And the original purpose is to serve the Chinese students' parents in China, since they are worried about how the children's condition is in medicine. So I firstly created the static map and then also developed that into the web version as a ArcGIS dashboards. So I have the desktop version and mobile version. I have the Chinese version and English version. Originally focusing on just medicine area, also expand that later to a statewide coverage. the key attributes of them, including the case of the COVID and the case density showing at the color plot. And these are the cumulative values. I also have the weekly value version, the historical value version, and from the overall version to the more demographic groups version. So this is the general user interface of the major product, the desktop version of the COVID dashboard. So the major area is a map, and we have some key indicators. And during that days, one of the things I need to do every day is to check this web page and see if everything works still fine, and also read the numbers. For others, maybe we just read the numbers. And we also have the pie charts, bar charts, line charts, things like that for the full functionality of this desktop version. And then I add more features like the weekly pattern or the detailed info dialog, and later add a temporal filter to check the historical values. And instead of just the cumulative case of everything, we also split that by demography and ethnicity groups. So these are the changes over time for different groups of people. And this is the expanded version to statewide, but very similar to the similar style to the Madison version. We also have the mobile version, which has the key features and indicators. Based on the statistics later, the mobile version actually has the majority of the visits. So in total, there are about 80,000 visits. After the pandemic. So I post them originally just in the Mad News, which is a local Chinese media. This WeChat public account. It's actually a group organized by Madison students. And I post the static maps every day there, and later change to weekly report and summary. This dashboard is also reported by the local media like Channel 3000 a couple of times, and also some local articles. So during this process, I really realized and witnessed the power of map in benefiting our local communities, which is confirming my decision to go into the field of cartography. And I really gained a lot of joy and experience during this map design or the web development process. Turns out to be over 800 images, mostly daily images. And then the dashboard has over 80,000 views at the end. It also brings me with some award from CAGES and WIA. And yeah, for everything I shared today, I mostly have them ready for a view on my website. So feel free to check. And after these years during the pandemic, I gradually focused more on static map designs, since I really have more joy and it's a more pleasing process for me to design the static maps. And I also gradually developed my own mapping style and habits. So right now it's the formal beginning of the presentation. I decided to show an illustration of my award-winning maps and categorize it into 4 themes. So each of them has at least one of the award-winning maps, so that you will learn something that is verified by the real expert. It comes from the research and then gradually far away. So the first one, hurricane trajectory realization, is either directly with my research or highly related to my research. And then I have expanded them to general disasters instead of just hurricanes, and then focus more on the multivariate thematic mapping as using the natural disasters or the hazard as a context. And the third one would be just out of my passion, like making reference map to the regions that I am familiar with or I'm concerned about. And the focus here is the hero shading techniques. And the fourth one is something I just developed this year, actually. So it's Lego style map design, and it's more like a creativity and for fun. So let's begin. You probably have seen this image. I use it a lot in my slides. It's actually a hexagon shape collage I made in the May of this year. So everything by that time, I have that displayed. The major maps have that displayed in this image, but some of the maps I mentioned, if it's after the May of this year, it's not displayed here. So these are the maps I'm going to introduce today within that 4 themes. So the first one would be hurricane trajectory realization based on these 2 maps. I'll introduce the bottom one at first. This is a Hurricane Harvey's users, or sorry, the Twitter users related to Hurricane Harvey's trajectory instead of the trajectory of hurricane itself. And the second one is the historical hurricanes trajectories. Okay. Yeah, so this is the revealing Hurricane Harvey map. I actually designed this to serve my research paper. This is also my first map to NACES. And it's a realization for my research paper based on the Twitter-based trajectories of the same Twitter user. So I connect the trajectories of them and realize their individual segments and aggregate the network. So the value of them is actually coming from the machine learning algorithms to detect transportation modes. So on these trajectory maps, the blue color represents flight trajectories and the orange color represents drive trajectories. And so the results are based on the spatial temporal characteristics of the Twitter trajectories themselves and also the textual information within the tweets. So there are some data mining process behind this. So I specifically put the map under the circumstance of the Hurricane Harvey into 2017. So that's something shown at the bottom of this map because we really care about where the spatial temporal pattern is under the certain status or phases of the hurricane disaster. And then I also aggregate them as a network or things like that. And compared to the previous maps, we have the four phases. So this one is of the overall patterns. The first map is aggregated by state, and the second one is aggregated by the smaller cities in Houston and Texas region. And this one is another exploration actually prior to the previous poster. This is unpublished work. I just make this for fun. This is a way to show the individual trajectories rather than the previous aggregated ones. So I designed a method to scale all the trajectories proportionally and also relocate that by either origins or by destinations and have this type of the wind road style, but not the same idea graphics. So we have the graphic for individual segments, and we also have that for the aggregated network, which just let me think about whether there are other ways to show them. So I make this huge table to think about all the levels, all the way from the raw trajectories to the adjusted ones, either by region or by cell, which means the unified spatial unit like the grid or the hexagons, or by distance, or by region and distance, or by cell and distance, things like that. So the adjusted ones is still having the same number of the raw trajectories. It's just changed somehow, but the aggregated one, the third level, is something beyond that. So we have the network, which shows like the aggregated level. We can still have some subcategories of this level. And beyond that, we can either generate the density of the trajectories or even make some cluster pattern and run analysis like spatial autocorrelation to get some hotspots. And in terms of the spatial components, it could be either related to points or lines or polygons or the cell units, which is a raster-based or the universal unit based. For each of them, it can be split by origin or by nested or by OD pair. So I feel this entire huge table is hard to see, but that is a way to help me think about theoretically how any kind of trajectory-based realization could be, and also present this one in the conference during 2020. And the second map under this theme is the historical hurricanes in continuous US. So this is a combination of 3 thematic maps, and including the hexagon paranomic one at the bottom, and the concentric rings at the top left, and the historical tracks on the top right. So the first 2 maps have the same unit, which is 10 square mile for the hexagons. And you can see there are a lot of information, and much of the information are related to time, especially for the first 2 ones. And the third one is just historical tracks. But I also designed an algorithm to decide how it can be displayed on the map and how it can be labeled. So the consideration in terms of cartography in this map, including the map projection, it's very clear that the one at the bottom is not a normal one. And also I designed the thematic map symbols for the two on the left and at the bottom. And then they are rich temporal information for each of them. They are kind of categorized in different ways, either just showed every 10 years or cumulative in a cumulative way. Of course, there are considerations of the visual hierarchy and the typography. So due to the time, the time limit, I don't have the time to illustrate them in details. But for the third one, I actually expand them and make it a standalone map, which only shows historical hurricane tracks in the contiguous US. And then I also redesigned the legend for this one. So one good thing is it can be very easily updated based on the database, which is just a shapefile. We can easily update this one every year. So this year I already updated them. So the season of the Atlantic hurricane season has been finished. And then this GIF animation highlights actually the new tracks in 2024, including 5 of them that make the landfall, such as the Hurricane Helene. And this is the enlarged version of the legend. And you can see I actually have a system, like a hierarchical way to display the hurricanes and also how I label them. Yeah, then we move to the second theme, which is a multivariate thematic mapping. I have 2 maps here, but only one showing this image because the second one is made after May of this year, so it's not displayed in this graphic. So we'll start with this basic one, the United States of Natural Disasters. So this is the one. So it's basically covering the entire US with some insets of the Alaska and Hawaii, and then some small multiples on the sides. For this one, I actually get inspiration from the old printing effects, such as the dots, the unclear dots of the halftone printing technology. And I put the 7 major hurricane disasters, 7 natural disasters, including the hurricane, as the contents of this map. And the spatial unit is 1,000 square mile hexagon. And based on this hexagon, I also highlights their boundaries by showing the population density. And also, if you notice, the hexagons are actually not displayed in the same transparency, because I use the transparency as another variable to show the number of FEMA declarations. And the small multiples on the left can really help us understand the pattern well. But due to the very nature of the color hue, there's no way that we use this rainbow spectrum style of the colors to serve the colorblind community. So that is something we might need to think about in the future. And some thoughts about the symbol itself. Actually, since we are already highly relying on the color hue, we should try to minimize the difference of the lightness or the value. So the lightness and the value are carefully controlled to minimize the potential variation. And also during this process, I tried a lot of versions of the symbol, all the way from one extreme case with full overlapping, which means all the 7 circles are overlapping with each other exactly, to the other extreme case, which is no overlapping. So the 6 or 7 circles are just split evenly within this hexagon unit. And it turns out to be like this is the way that works the best to show both the overall pattern and provide capability to retrieve the individual attributes. So I also need to consider the functionality as well as aesthetics. I'm sure there is no perfect solution to arrange the 6 or 7 disasters in this circular or hexagon shape, but I still make some efforts to try to maximize the potential cognitive association visually, such as the red color for the wildfire type. And then I upgrade this one to a more complicated version. I still keep the same structure, It's United States blooming risks. And even the layout is kind of similar. We still have the small multiples, but I add one more map at the bottom showing the overall pattern, which is the values calculated like the average. And this time we have 18 variables, and even they are sharing the same hexagon units because I'm reusing the old unit, using the old hexagons. So that's why I call this a sister map of the previous one. They are sharing the similar design idea and even layout. But the differences are like the density of the hexagons are removed because this one, the data is from FEMA. They already consider the factor of the population in their scores. So I removed that top density layer, but also add the overall pattern because the overall pattern is not that clear in this map. And the data is more reliable since the 18 types are generated from FEMA's official National Risk Index instead of choosing by myself. The previous one, the 7 variables are just chosen and calculated by myself. But this one, the data source is more reliable. But due to this extremely high number of variables, 18, the design of this flourish symbol or the blooming risk becoming extremely critical. So how I designed this, I really need to consider the level of the lower overlapping. Even the previous 7 variable version, I test a lot of ones just to find a good balance between no overlap and full overlap. And for this one, it works in a similar way. And also need to consider the arrangement of the 18 variables, as well as which color each one is assigned. So that might be a very challenging task. So this time I use AI or ChatGPT specifically to help me design the color wheel. So this color wheel is actually not a standard one. If you look at it carefully, you might notice that the proportion between yellow and red is larger than the normal color wheel. Because I asked ChatGPT to do that for me, to design a color wheel, providing the hexagon code, the hex code for the 18 colors, but enlarging the red to yellow area. Because our human eyes have stronger cognition to these colors. If you use a standard color wheel, it turns out to be the entire map is very bluish, greenish, things like that. And FEMA actually only provide the list of the 18 hazards, and they have the process to prove that these 18 hazards are the most critical ones to the United States. But beyond that, there is no order or hierarchy of that. But to me, I have to decide a way to display the 18 hazards in this wheel and in this circular order specifically. So I use ChatGPT again to help me decide. I first asked it to describe the mechanism and characteristic of each hazard, and then ask it to create a similarity matrix, like 18 by 18 matrix quantitatively, and then generate a circular order considering this matrix, trying to make the similarity ones as close to each other as possible. So the closer ones, or the one with the pairs with higher similarity will stay closer, almost close to each other, and the further will be stay far away from each other. But at the end, I still manually adjust it based on my personal understanding of meteorology and natural disasters, and then finalize this. And at the same time, I come up with a strategy of categorize them a little bit, not very accurately. For example, the purple and the blue and the red are representing the meteorological related hazard. Also the red representing hot and the blue representing cold. And then for the others, they are generally follow the idea, the order that ChatGPT is provided. And then the geophysical or the geological related hazards are showing green color. Even in this small image, you can notice that the West Coast in the United States is more greenish. That's because there are more hazards related to geological reasons. Yeah, this map, this image shows the 6 major regions in the United States. You can generally feel like the pattern is different, and each region is having a certain focus of the hazard. So this is the end of the second theme, I think. And then, okay. Yeah, the third thing would be reference map field shading. So here I have 3 examples, but only 2 are finished before May of this year, which is the Taiwan map and Zibo map. The third one is the Israel-Palestine map I made later this year. So instead of go through each of them one by one, I decided to show them at first, and then display and discuss the hill shading technologies generally. So these are the 3 maps. They are in a different layout, and then but all of them have the hill shading. Even the color looks different, but the mechanism or the methodology behind the hill shading generation are very similar. So I will give the full credit to John Nelson. I watched a lot of videos on him, and that's where I learned the hill shading methodology. There are way more ways to do that. You can generate hill shade in R or in Blender, but I personally really love this way. Like I can control and this hill shading in a very relatively simple and understandable ways. So the required data is just the DEM. So in this case, I use the 30-meter SRTM elevation data as the base. Optionally, you can have the sample images or land cover land use or bathymetry or the contour lines generated from the DEM to assist you, but only the DEM is the required one, the only required one to generate such hill shades in ArcGIS. And yeah, here are the 3 enlarged images of the hill shade of the 3 maps. So for each one of them, it's actually a combination of, in my case, 20 or even 30 layers in ArcGIS Pro. And I need to adjust their blend mode and their transparency and sometimes related to the order of them. But mostly it's about the blend mode and the transparency. And also there are other parameters such as how I generate the blurred version. So I can introduce the general idea here and also list a very brief framework of like how I list and set these layers and like their configurations of the blend mode. But actually the general idea is you have the original DEM, which is the original version, and then you make the blurred version of the DEM at different levels. But how you control this blurred version or how you set the parameters will play an important part. And later you can focus on you can focus on different blurred version by setting them to be different transparent. So you will have different styles of the hill shading, even if it's just based on the same DEM. Another thing I didn't list here is the color scheme. You might notice probably the Taiwan one and the Zibo map are kind of similar. So the mountain regions are displayed in green color because that's the forest. But for the Israel-Palestine, that's really not the case. The higher elevations are not covered a lot with vegetation. So I apparently use a different color scheme. So this is something as we as cartographers will have a lot of space and creativity to play with. The general idea is like setting the layers in such ways. I don't need to go over the details, but you can see it's either based on the original DEM or the blurred DEM or slope of the original, slope of the blurred, hill shade of the original, hill shade of the blurred. And there's another additional layer called hill shade of the slope. This, I believe, is something created by John Nelson himself in a strange way, because this doesn't make any sense literally, but it works really well practically. So usually I will also include that. And then every time I just change the different details by playing with different values of the transparency or coming back to generate differently blurred version of the layers, and then follow this order and the settings to combine them together. Then you will have the hill shading layers like these. Okay. So for the Taiwan map, I can introduce more like the projection. Yeah, it's also not the normal one. It's also graphic projection called Earth from Space in ArcGIS Pro. So by changing the parameters, you can find the best way to display the pattern while still keep the common coordination of north and south. So in this case, I view the Taiwan island from southwest, and it can be displayed here from the locator map. I have a enlarged version of the locator map here. So that's the projection part. I try to balance them well. That's also my general strategy to decide such a customized projection, which I use later again in the Israel-Palestine map. And then this map is a trilingual or 3-script map. So it has an English label and traditional and simplified Chinese characters label. Since I'm relatively familiar with both types of Chinese characters, when the labels are the same, I will remove one of the duplicate one just for simplicity purpose. And this map is supposed to be non-political one, so I try to focus only on the natural features. The cities in the main map only has a very subtle labels. But on the right side, the top right, I have a map showing the administrative boundaries and distribution of indigenous groups. Also, just keep the minimum level of understanding the spatial, but do not focusing too much on the political elements. And then the Zibo map is something I made with my full passion since I grew up here. So this is the a range of the administrative units of the city with the locator map on the top right showing where it's located in the Shandong province. I designed this map originally just for the Chinese audiences. So that's why I don't have to introduce where Shandong is located in China. So everyone is familiar with that enough. And we also have a zoom in map on the lower left showing the central urban area, which is also where my home is located. So I'm very familiar with this region. And when I was a child, I usually travel to the mountainous area just for trip for holidays. So I have a lot of memories associated with these POIs points in this map. So the focus here is the POIs of the tourism and also some transportation lines and train stations or highway stations, things like that, just to serve the tourism purpose. We have the inset map and the locator map. And the locator map of the Shandong province is also including the hill shade layer. So you can see where this city is located in that province and why the southern part of the city is mountainous. And we also have a lot of graphic designs from cultural or historical or any local elements from our city, such as the north arrow or scale bars or just as a standalone graphic. And for the city map or the street map, I apply the transit map style symbols for the lines. And these are the special temporary bus routes during the tourism season in China. Yeah, so I make this map with full passion as a native. And this map is the one I made during this year. And at that time, the Gaza Strip is the global conflict, one of the global conflicts. So I choose this projection. On the one hand, just as I said before, better showing the terrain, which is kind of similar like Taiwan, relatively plain on the west and mountainous on the east side, and also keep northeast up. But also the other consideration is, in this case, I can just put the Gaza Strip right in the middle. Where's my mouse? Right in the middle of this map, right here. So yeah, this oblique view is actually achieved in the scene. It used to be called the arc scene, but right now it's part of the ArcGIS draw. But I would not recommend this way. This is just my experimenting map. I will not do this again anymore because everything in scene is not editable. If you export them, it will just be a raster image. Yeah, so I have a hard time adjusting those. So this will be a good lesson to learn. And I'll represent the landscape better with the land use and cover data, which I haven't used before to make a hill shape. And this is also supposed to be a non-political, non-religious map. So I only include the minimum elements of the political boundaries, such as the countries, just for referencing purpose, and the major cities, and also the modern place names of the physical features rather than from any religious background. And also, I choose this way to show the extent and the perspective, and then making the further region looks like fade out like a mist. Yeah, then we move to the last part of the talk, which is the Lego style map design. So I put two maps here. This is the only two map I made before May of this year. Actually, I'm a relatively new Lego fan. I'm not that familiar with Lego prior to this year. But once I get started, I'm addicted to it. So at that time, I only have these two, but I will not show the details of these two. Instead, I only put this poster here where I also bring to Kinesis. Oh yeah, since you are here, you can also see the physical image, not image, sorry, the physical one of the Wisconsin Lego map and the North American Lego map, and there are also others I'll introduce later. So I previously gave a talk during Kinesis conference. It's about 8 minutes. If you want to generally know the idea or the process, I designed all of this. You can watch that video. If you're interested in the technical details, I previously gave another guest talk for GIS Colorado, I think last month. So that guest talk is 1 hour long, focusing on more detailed part of the making this, especially related to the Lego Studio, which is the software I use to render the 3D version. Like here, the Colorado one, the New Zealand and Arizona are 3D rendered using the Lego Studio. So I'll skip this part and talking about the general thing very briefly. So there are significant difference between any of the previous Lego maps because I'm always trying to try some different designs. But they are sharing the similar workflow and design style in ArcGIS Pro. So I will usually design them like visually and sometimes need to calculate because I need to decide based on the size of the base plate. For example, these two is like 32 by 32, I guess, or 38 by 38, 36 by 36, and the larger one, I'm sure is 48 by 48. I'm not talking about the measuring length, but the unit of the number of the Lego units. So by size, it's like 10 by 10 or 15 by 15. So these are the factors you need to consider when you design the maps visually. And you also need to consider the scale. For example, the Wisconsin one, I'm sure like one tile represents 10 by 10 square miles, which is very easy for us to understand, and we can easily measure them by just counting the number of the Lego parts. And also the extent is another important factor, because later I gradually try to mimic some old map styles by breaking the neat lines. So if you see the North American map, you will see the map neat line is broken in several. Not too many, but some of them. So this is also another factor you need to consider when you plan them visually. And the technical part would be just calculating the values. I exactly extract the values of the center point from DEM. And that center point is generated from the fishnet generated earlier in ArcGIS Pro. But feel free to try other ways. I'm sure there are other ways like in QGIS or using R, just directly getting the DEM. And it's more, maybe more scientific to show the terrain by not only extracting the center value, but instead calculate the average value. Because sometimes when I manually decide whether to adjust, especially for the coastline or something like that, I do need to make sure that it will match our general common sense of our geographic knowledge. Sometimes extracting the values from the center will make such silly mistakes. And then I apply the Lego style symbology, including the classification of the topography and also the symbolization of them. So even in ArcGIS Pro, I try to mimic the style of Lego so that I can generate some pure graphic from ArcGIS Pro and maybe use that as part of the later maps. But I didn't dive too deeply into this part. You can also check John Nelson's video. He has another series of things about mimicking the Lego style symbolization in ArcGIS Pro. And the next step is to build up the physical model or build up the virtual model. So if you want to build a physical one, you do need to calculate like how many of them you need and then buy them. I am used to buy them on eBay. Like if you buy hundreds of the same thing together, it will be much cheaper than you buy from the official ways. And also, if you want to try Lego Studio, then you have the total freedom. But for the color, you can only choose the color that Lego has. It's not like the things in Illustrator, you can pick whatever color you want because Lego only have certain colors. And also Lego has a lot of interesting and sometimes weird shape you can play with in Lego Studio and build up your virtual model over there. Yeah, as I mentioned, for the detailed methodology, feel free to check those two longer presentations, which I will not duplicate today. But I will play a very short clip of the two maps. Yeah, you already see the physical version. Okay, and then I try something beyond the topography. So this one is a map of Ukraine. It still has the topographic information by raising the heights of the terrain for the mountains area. But I only use the same color because that's the only thing I have. I didn't purchase another round from eBay. So I'm just making these using the existing materials I have. So this one has the Ukraine region displayed in red color, yellow color, and with the red color displaying the invaded area by Russia. And the flag also indicating the real flag of Ukraine has which has a blue and yellow color, shows the location of Kiev. And this is the one I made during the US presidential election. And the first image is rendered in the Lego Studio and also edited in Illustrator. And the second one is a picture of that. But I later realized I made a mistake for the position of California. Just ignore that because it's too high. Right now you can see how high it is. And considering the structure of Lego is not that stable. So it's very easy to like make the California one fall off. That's why I misplaced it in the wrong cell. But you can still see the idea, like this is a cartogram of the United States. So each dots of each piles represents the single states. Yeah, most of the states will have the same color, except for the state of Maine and Nebraska, I guess. I just put them proportionally to the votes. Yeah, and the D and R representing the Democratic and the Republican, also showing the left and right. Oh yeah, it's another video. Just for the people online, you cannot see the physical version. And after that, I built something for fun. Yeah, you can see this is the hemisphere world map. One is the physical geography, one is the continental geography. Yeah, very abstract, very overgeneralized. And yeah, this is another one I really love. So I get inspired by the local photographer here in Madison, Stephen Kennedy. And I really love one of his maps. He is using the style of the Madison city flag. So this graphic on the top right is the official city flag. Actually, it's a map. Yeah, if you're familiar enough with Madison, you can easily recognize that the yellow dots is representing the dome of the Capitol building, and the 4 black is the Capitol building's 4 wings. And then the white part would be the isthmus, which is the land. And then the 2 blue part is Lake Mendota, Lake Monona. So I really love the city map and the city flag. and also like the map that Steven made. So I make this Lego version. It's a 3D version. If you see the first image, or you can see the Lego map, you can notice that the dome is higher than the Capitol's building, the wings, which is higher than the isthmus, which is higher than the lakes. And this is the last one, which I'm not sure should be considered as a map or not, because this is during the 30-day map challenge in November. So I noticed others are making a map of their room which belong to the category of micromapping. So I guess that makes sense. So I tried to make this one, but it's more like a model instead of a map. Yeah, just for fun to play with. Yeah, so that is all about my presentation of the map today. So a very short summary. I really enjoy the map making process instead of just the final version. Sometimes there's no final version. I keep updating them, and sometimes I just keep making branches, just like the GitHub repositories, making branches of the map and cannot decide which one works the best. Then I will ask others for feedback. So yeah, this is something I learned, that always archive everything in an organized way. And also I learned from others. This is very important to me, even just looking through the random maps on social media posts. And right now there are a lot of resources we can learn from, and which is very good for us to get inspired. And also the shortcut, which means sometimes you can learn very easily that you didn't realize to make a map. A very good example here is the georeferencing. So when I learned georeferencing is in our map, everything in my brain is just click one map and then zoom, and click another map and repeat this process. And then one day I see Brian is making the georeferencing in ArcGIS Pro, and she used the scale and move function, which I didn't notice at all. So this is something very easy, but I just really don't know. Yeah, something like that. And this is not the only case. I have lots of examples such as this one. You can learn something super easy from a person that you don't think he is good at, but that's it. Sometimes you just simply ignore some very basic or some smart ways. So that's why I list a shortcut here. And the methodology will be more systematic, such as the John Nelson's video, Daniel Huffman's video, blogs, things like that. And also, I really enjoy combining my other experience from other fields with maps. For example, I previously have a habit of carving stone seals, which is a type of Chinese calligraphy. But I gradually realized that some of the layout experience in map making comes from my previous practice in seal carving. I already carved like 100, less than 200, but more than 100 seals. And you do need to design the layout of that seals. And sometimes I found some strange but true similarities between map making and seal carving. And also the seal carving indicates like the upper and lower level. Sometimes it shows just the same way as a hue shading. It helps me to understand how the shade is working. Yeah. And calligraphy, yeah, for sure, especially for English calligraphy, it's highly related to topography, so I don't need to emphasize here. And for painting, no matter which kind of painting, yeah, if you have general understanding using color in painting, that would be really helpful in using color like in map making. So I was not a painter at all. I just recently started learning watercolor, but I still think I can combine painting and photography in a very interesting way. And then the other part is like outdoor activities such as cycling, running, hiking, jogging. So if you have the habits of keeping your tracks digitally, then it will be very good to make some maps, like using your personal experience or memories. And I do not think it's a waste of time to manually log those routes. For me, it's just like a process of revisit these places. So it's a very joyful process for me. And at the end, it's a craft. Of course, there are a lot of things we can combine. That's pretty straightforward. And this year is the first time I practiced in the 30-day map challenge. previously I didn't try since I always think the schedule is too tough. I cannot finish that. And I don't think things people post are finished in one day based on my personal experience. But right now I changed my mind. I think it's okay to only participate several of them. And especially I can use this chance to clear out some unfinished map. So I'm sure whether, yeah, I guess you probably have the similar habits, which is to try something, experiment, but then give up and then make the final map. So I have lots of such temporary project file in Atlas Pro. So I use this chance to pick up some of those I really care about and make it a finished map. So I really think this is a good way to participate in the challenge. And also, I can also update existing maps. The updating part definitely can be finished relatively soon compared to make such complex from scratch, such as the updating the historical hurricanes. So I already have the previous ones. I only have the new shapefile, and then I can quickly update relink the files and make the new map up to date to this year. And also it's a good chance to try some new craft maps. Yeah, so that is the end of my presentation. Our cartographic journey never ends. Lastly, I would really want to thank all of you and all of my colleagues from CarLab. Many of the maps is actually revised several times after getting feedback from professors, from students, from all of you. So I really appreciate, and yeah, so hope my talk will bring something bring some inspirations to you, and then we can communicate more. I'm really happy to.
You guys have time for questions, but if you have time at lunch and want to stick around, people want to just individually ask questions or.
Sorry about the timing and showing up late. I actually has another guest talk, same content I'm choosing this morning, so I'm using the same slide twice. Yeah, so I'm coming late. Feel free to take those slides.
Thank you.
Okay, I'll stay here for. Thank you for online people.
Just to clarify for